Welcome to Poly Pomona's URP 3350 class, Plan Making History and Future. Today's presentation is on the textbook Urban Land Use Planning by Berke, Godschalk, Kaiser, and Rodriguez. This presentation will focus on Chapter 6, Environmental Systems, and my name is Scott Reimers. Chapter 6 deals with two parts. The first part is focusing on the environmental inventory you would perform when you're doing a general plan or comprehensive plan update or even a specific plan. You'd first take a look at what the environment includes, and so you would look at the topography and slope of the area. You would look at soils, wetlands, landscape fragmentation, and wildlife habitat, watersheds, hazards, and other sorts of environmental situations. And then in part 2, we would look at the methods of evaluating these different environments. So there's 3 main methods that the authors talk about. There's land suitability analysis, environmental impact assessment, and carrying capacity. So the first environmental condition we're going to look at is topography and slopes. And we look at that through what are called topo maps or topographical maps. The purpose of these maps is to show the shape of a slope and the elevations. It does that by giving you different elevations. It will also show you how steep different slopes are. So the whole purpose of this map is to render something in 3D, in 3 dimensions, into 2 dimensions. Now with more sophisticated GIS systems, like even Google Maps, you can now see stuff in 3D. But this is a 2D way of showing something in 3D. These are produced by the U.S. Geological Survey, and it will include a few features. There will be definitely natural features. It'll name different peaks and rivers and valleys. They'll also name some human features to give you a sense of context, and it will have a whole set of contour lines, and that's the main point of the map. So here's an example of a topo map from the U.S. Geological Survey that centers on the area from Monrovia, Duarte, Azusa, and Glendora. So we're talking about the 210 corridor where the 605 meets. And on this map, we can see some contour lines. So there's contour lines here. That's a contour line. You have a whole series of contour lines here. These are the lines that are kind of shown in that brownish red color. We'll also see some names of man-made features. So there's the designation of the 210 freeway here. It'll give you place names like some cities, Azusa and Glendora. It might give you some names of communities, some streets, and so forth. So here's zoomed into the area where further up into the hills and the mountains, and we can see here's a natural feature. This is Monrovia Peak, and so that's labeled. And then we have areas where the lines are very close together. Here, for example, that's going to be an area that's very steep. And then you have areas where the lines are further apart, and that's where things are going to be more flat. So the dangers can occur when dealing with slopes by placing buildings too close to a slope that's unstable. Disturbing a slope can also result in additional instability. So you want to try to leave slopes alone as much as possible and place those buildings further away from them. You can create additional instability when you do cut and fill. That's when you cut one area of a slope and you fill another area. So what you typically see is you see somebody cut the peak off of a hill and dump all that excess soil into the valley, and you try to create less topographic change. That can create instability. If you remove a lot of plant and you deforest that area, that can also cause a lot of instability because that vegetation is helping absorb all the water. Once you remove the vegetation, the soil is now absorbing it, or it's all just running down the hillside. And then altering any natural drainage courses, that's going to just accelerate your erosion and create additional instability. So where does land use and soils intersect? That's what you need to consider when you're considering what land uses to put where, is that, first of all, you want to put in land uses that are going to require a minimal amount of slope modification. So a large commercial development on a slope, not a good idea because you need to have all that room for parking and large, Best Buy, that's going to take up a big footprint. So you don't want to place those types of uses in areas where there's a lot of slope. Very not dense, very spread out single family neighborhoods where you can spread the single family units out away from each other is what you want to do in areas that have a lot of slopes. So the whole point of that is to minimize slope modification. And you want to try to put uses where they're not vulnerable to slope and slope conditions. So moving them away from a slope, on the edge of a slope, or at the bottom of a slope. You're going to increase landslide dangers when you remove vegetation. So even if you're going to have a single family development that's on or near a slope, you're going to want to try to put an ordinance in place that requires them to keep as much vegetation as possible. You're going to want to try to reduce cut and fill as much as possible. And then make sure those uses are as far from the slope as you can afford, and then you're going to want to make sure that you investigate soil and bedrock composition. So typically when you're doing development on slopes, what you're going to do is require a soil and geological study so that the engineers know how to build the building given the composition of the soil. So this is an area just next to Poly Pomona. This is on the 57 freeway looking north. This is the 10 freeway down on the ground there. A few years ago, this whole slope pulled away from the side of the hill and ended up on the interchange from the 10 west to the 57 north. And that's the picture that's here. So this road here is the road coming up from the 10 freeway to the 57. This is the 57 right here. And you can see all of this soil fell down on top of the road, and the interchange was closed for a couple of months as they removed the soil and then had to regrade the entire hillside. So what can we see in this picture? We can see that there's a lot less vegetation here, and so that might have had something to do with all the erosion that occurred. You can see in this area here, there was quite a bit of vegetation, and that's probably keeping the soil in place. There's vegetation here, but in this area up here, there's a lot less vegetation. Did they do cut and fill? Oh yeah, they cut up this hillside pretty well in order to put in the interchange. Were there dangerous uses adjacent to the slope? You can argue, well, at least there weren't single family homes adjacent to the slope or a daycare center or something like that. But putting traffic that close to the slope did put people in harm's way. Thankfully, nobody was driving at that part of the road at that time, and no one was hurt during that collapse. And soil composition, what was it? I don't happen to know that, but that definitely would have had some involvement in the movement of that soil. So when looking at slopes and coming up with regulations and ideas about how to preserve slope, the book doesn't cover this, but I thought I should cover it because this is considered best practice, is that when we're talking about designing with and around slopes, one of the goals we should have is that the structure can't be seen from the valley below. And so if you're this person standing here, this building has a lot less prominence while it's below the top of this ridge. Behind the building is additional hill, so it kind of blends into the hill more. So you always want to make sure that new structures, if you have to build on a hillside, are not set at the top of the peak. That only makes them much more visible to people who are down in the valley. So in this city, I think this we pulled from Pasadena, required that the top of the house has to be at least 30 feet below the top of the peak. So when you're looking for information about soils, you would normally think, well, I'll go to the US Geological Service because they're all about the ground, right? No, if you're looking for soils information, you're going to want to turn on the Department of Agriculture, which if you think about it makes a lot of sense. Who is more interested in the quality of soil than farmers and the Department of Agriculture? When you're looking for this information, usually it's because you're doing some regional planning or community-wide kind of general plan type review, trying to figure out which areas do we want to protect from development, or do we want to keep it agricultural because the soil is so good, or this area will not be good for development because there's so much clay in the soil and we're going to have problems with development in the future. So we've gone over slopes and now we'll go over soils. There's a lot of different aspects to soil. Some of those different aspects include weight bearing capacity. That's how much weight can the soil bear. So soil that tends to be more gravel-like, more sand with more sand in it, that can hold a lot more weight. Soil that's more like a clay soil, that doesn't hold as much soil. Shrink well. Shrink well is the characteristic of soil that is just about shrinking. When that soil gets a lot of water and then dries out, what happens to the soil? Sandy and gravelly soil doesn't tend to move, doesn't tend to change. It's the clay soil that when it goes from being wet to dry, it ends up getting all those cracks in that, and that's not great for building on. Infiltration capacity is how much water can the soil infiltrate? How much water can infiltrate into the soil? And it's the more organic material you have in the soil, the better. So soil that has a lot of sand and gravel in it will also have more infiltration capacity. Clay soils tend not to be able to absorb a lot of water. So the way you would improve clay soil is to add amendment to it that's organic. So think about mulch and things like that. That's how you would improve that. Erodibility is affected by 4 different things. One is vegetation. If there's a lot of vegetation on a hillside, that soil is going to stay in place because there's a root system that's going to hold it there. That's why, like, after we have a major fire and it burns out all that vegetation, everyone's concerned about mudslides. So erodibility is affected by vegetation, the type of soil. Obviously, if you have soil that's very sandy, that's very high in erodibility. So think about when you're playing down in the ocean and you have building sand castles, that sand can erode into the ocean very quickly. Third one is slopes. The steeper the slope, obviously, the more it's going to erode because of gravity. And then lastly is the amount of rainfall. So areas that have a lot more rainfall are obviously going to have a lot more erodibility. Slope, we've already talked about, so I'm not going to cover that much more. Depth to the water table. Areas that have a very high water table, that means the water that's in the soil is very near the surface of the soil. Does not bode well for development. You don't want to have water coming up from the soil into a building. So having a lower water table for that respects is good. Sometimes that water table is going to change a lot depending on the amount of precipitation you've had. And then lastly, fertility. The more fertile the soil, the more you're not going to want to use it for residential and commercial development, industrial development. You're going to want to save that land for agricultural purposes. Probably where I run into the most this in my city is where we now have a lot of what's called low impact development. And the idea there is stop sending all this water out to the sea and let it infiltrate into the ground. In some portions of a city, you're not able to do that because either one, the groundwater level is too high and the water is not going to infiltrate back into the groundwater, or if the soil is very clay-like, it has a lot of clay in it, then the water is just not going to infiltrate into the ground. And so you have to come up with different what are called best management practices to get that stormwater to infiltrate into the ground. So from soils, we'll move on to wetlands. Wetlands used to really be known as a wasteland or a swamp. And the more we've looked into them and found out about them, the more we found that they're quite the asset. It's an asset because there's all these benefits to them. They are a place of habitat. You know, when you go down to a wetland, you see lots of birds flying in. They're all chasing fish, and there might be snakes and frogs and toads and all sorts of things happening there, and that produces a lot of habitat. It's also a place for flood storage when there's a lot of flooding occurring. It's a place that traps sediment and cleans it, traps nutrients. There's also just scenic beauty that occurs there sometimes, maybe not all the time. It helps with shoreline erosion control and helps protect the groundwater. So what is a wetland? How do we define it? So first of all, there has to be surface water. There has to be water that for the most part of the year, for a considerable period of time, there has to be water that's available. The soil has to be saturated again for most of that time of year. And then plants that grow in saturated soils also have to be there. So you have water throughout most of the year, you have saturated soils, soil saturated with water, and then you have plants growing in those saturated soils. And so the U.S. National Wetlands Survey classifies wetlands into 5 different categories. There's the marine wetland, that's a wetland that's in and around deep water. There's the estuarine, or like an estuary, that's in shallow salt waters, almost like a marsh. So if you've been to Bolsa Chica State Beach in LA, the whole area down there is an estuarine. Then you have riverine, which is a wetland that's occurring next to a river or a freshwater stream. There's lacustrine, which is a standing water body like a lake or a pond, and then that's acting as a wetland. And then you have polystrine, which is an inland marsh, a swamp, or a bog. So after talking about the dead and inorganic world of soils and slopes, we finally get to some living creatures. So we've got the next portion on landscape fragmentation and wildlife habitats. And fragmenting landscapes and habitats can create a threat to biodiversity. And keeping species and not allowing them to go extinct provides us a lot of different benefits, more than beyond than just the aesthetic benefit of having cute animals around still, but they can provide medicinal benefits. Certain plants can. It also provides biodiversity. It allows other species to thrive. But if you get rid of one species, it can have an impact on other species. So landscape fragmentation also reduces the mixing of isolated populations. And on the next slide, I'm going to show you a project that impacts that. So when we're looking at landscape fragmentation, one of the things we want to do is make sure we're buffering new uses from areas that have important landscape features, plants or plant communities, habitats, and then also wildlife habitats. And so one of the ways you can do that is you can say, for instance, there must be 50 feet between each single family house, or there has to be a new single family development must be 100 feet from this habitat. And so those would be buffering and siting development requirements. So you're siting buildings further away from each other so that you're not affecting as much of the habitat, and then also requiring the human features to be located closer together keeps the habitat from being fragmented. So this is an example of the mountain lion locations that have been seen in the Santa Monica Mountains. So this is the 101 freeway. I have to use my highlighter. This is the 101 freeway in California and the LA area. This is the 118 freeway, the Ronald Reagan freeway, as it comes down from the east and then down south. So you can see the mountain lions have been spotted all over what's known as the Santa Monica Mountains. But then they've also been located here just to the north of the Santa Monica Mountains on the other side of the 101 freeway. And so this would be a wildlife habitat that's been fragmented by the 101 freeway. And so in order to deal with that, what they found is that the mountain lions that are in the Santa Monica Mountains, that there's a lot of inbreeding going on. That's obviously not good for wildlife habitat. And so in order to allow for the mountain lions to join other mountain lion habitat, other mountain lions, and they've provided these wildlife corridors. And so they're building a wildlife bridge that goes over the freeway, the 101 freeway, and allows mountain lions to pass safely over the 101 freeway. So the most important legislation in regards to fish and wildlife protection is the 1973 Endangered Species Act, which set the U.S. Department of Fish and Wildlife as the key government organization that's responsible for tracking fish and wildlife. And so if you're looking for information about wildlife communities and habitats, that's the organization that you would go to. So Fish and Wildlife prepares species recovery plans, and then they will provide you maps showing the location of these habitats. I should say that when you're looking at habitats, what your goal should be is not to have a bunch of small portions or fragmented off portions. What you're trying to do is create one large habitat of that area. And so large patches are always better than smaller ones, and a single patch is much better than a bunch of smaller patches. So now we'll just say a little bit about watersheds. Watersheds really can be huge areas. It can be hundreds of square miles. So when we talk about watersheds, what we're really talking about in the Los Angeles area, Southern California area, are sub-watersheds. And so we have smaller rivers in the LA area and the Southern California area. But this example here on the left is the San Gabriel River watershed. So here you've got the San Gabriel River, that's the main one here, that runs all the way from Seal Beach up into the mountains. And then you have a bunch of smaller rivers and washes that are feeding that, all the way from those that are up in the mountains. You have the North Fork of the San Gabriel River, along with the East Fork that lead to it all the way in the north. And then you have some washes like the Eaton Wash that runs through Temple City. You have the Rio Hondo, which runs through El Monte. Then you've got Walnut Creek, and then you've got the ones that are in Orange County, like Carbon Creek and Coyote Creek, all leading into the San Gabriel River. Now, the subwatershed is all the land that contributes water to each of these creeks and washes, and then ends up providing the water that goes into the San Gabriel River. And so when we're talking about watersheds and land use, what we're really talking about is the problem that's created within that watershed, which is the amount of impervious surfaces. And what I mean by impervious surfaces are surfaces that keep water from going into the ground. And so that can be anything from a roof to concrete, anything that keeps water from getting into the ground. And so part of the concern with all these impervious surfaces that we have in the Southern California region is flooding. So when it rains and you have an area that's natural, a lot of that water can get into the ground. But when you have a lot of impervious surfaces, that can push all of the water off of the concrete, off of a roof, into the wash, and then into the river. And that's why the San Gabriel River goes from being a trickle to a huge roaring river during a rain event. It can also result, having all this impervious surfaces can lead to a loss of aquatic life, and then increased pollutants. That's the real big thing we have in the Southern California area, is that all of this area in the watershed here, because this area is mostly built out, you have a lot of concrete, you have a lot of streets, and as the water falls on the streets, it picks up pollutants, all that tire that's been ripped up, all the oil that's been dropped, any other automobile substances, even stuff from restaurants that they pour out into as they're cleaning their mats, soaps, dog waste, all that type of stuff gets pulled up into the water and then gets put into the streams, washes, and the river, and then ends up in our beautiful beaches. And all that stormwater doesn't get cleaned. For the most part, when it rains, all of that goes just straight out to the beach, which is why the beaches end up having to close after a rain event because the water is just so full of pollutants. And then all that impervious surface also reduces the amount of groundwater because the water is not getting caught and then percolating back into the ground. It's just being sent off into the rivers. We are seeing a lot more movement on increasing pervious surfaces. LA County adopted what's called Measure W, which puts a parcel tax on every property based on the amount of impervious surfaces on those properties. And that funds projects to increase pervious surfaces in communities. So the next time you see a park project, you might find that Measure W funds went in there to expand the park to help create more stormwater capture. We're doing more with parking lots, trying to get the water during a rain event to go from the parking lot into the landscaping around the parking lot, so that water gets put back into the ground. So when we're dealing with watersheds and stormwater runoff, the most important law or set of rules is under what's called NPDES rules. You'll hear it NPDES said really quickly by engineers. That's the National Pollutant Discharge Elimination System. And then you have the MS4 permits. So I think it's county in the Southern California region has to get an MS4 permit. And MS4 is really describing that there's 4 S's in the abbreviation. So it stands for Municipal Separate Stormwater Sewer System, M and then 4 S's. The requirement of the MS4 permit right now is that the first inch of rain has to be managed on site. So the goal is that when it rains, if there's an inch of rain, all of that water is not leaving the site and it's getting picked up and put back into the ground. And what that requires, so that requires you to install what's called a low impact device or a lid device. And a lid device could be something like bioretention or a rain garden. So if you have a residential project, you might put in some swales in the landscaping so that the water from the parking lot goes from the parking lot into these swales or dips in the ground, and then the water goes into there before it goes out into the street. It might be a rooftop garden. It could be some vegetated swales, which I just talked about. Could be some disconnected rain downspouts. So rather than the downspouts going out onto the street, the downspout might stop in a landscaping area. Could be rain barrels and cisterns. So in our city, we require new single-family homes to put in rain barrels to collect that water that comes off the roof and then use it for landscaping later on. Or it could be permeable pavers. We're also seeing disconnected concrete areas. So a driveway might be just a series of concrete pieces, or they could be disconnected from the sidewalk. Then the hopes that the water, when it's leaving the driveway, goes into the ground rather than going from the sidewalk down the driveway and then into the street. So the last section that we're going to look at is hazards and floods. So when you're doing a general plan or a specific plan, the last environmental section that you want to look at are hazards and floods. So the way you start that is by going to FEMA, or the Federal Emergency Management Administration, and they're the ones that put together what are called flood maps, and that's through the program called the National Flood Insurance Program. And to ensure that people can get flood insurance, the federal government has put together this program. And so what they do is they look at what are called flood-prone areas, and these are areas that would be expected to flood in 100 years, in a 100-year period of time. And so that's what's called the 100-year floodplain. And if there's a 1% probability of flooding within a 100-year period, then it's going to be included as a flood-prone area. Now, in order to get flood insurance through an FIP, the city has to, or the jurisdiction has to adopt some building and land use standards within that floodplain. I think that's about it. It's about as much as I need to say on flooding. All right, in Southern California, we're going to spend a lot more time thinking about the seismic activity rather than flooding activity. So this is on your left a picture of the seismic map. So this is produced by the USGS, or the United States Geological Survey. And this map's going to show you both the location of earthquake fault zones, and it's going to show you the magnitude of the potential earthquake on those different faults. So this is near the north of the 210 freeway. This is the 605 freeway in the cities of Monrovia and Sierra Madre. But in the next slide, I want to show you a liquefaction map. So this is a map along the 605 freeway near the area of Temple City and El Monte. This large piece here in green is what's called a liquefaction zone, and they tend to be around river areas, and it's ground that tends to be, when there's an earthquake, it has the potential for the water getting saturated into the soil, and then as that soil becomes saturated with water, the building on it, the ground's no longer stable, and the building on it can move. Swimming pools can come up out of the ground. A lot of weird stuff can go on. So if you're in a liquefaction zone, the building code will require development within that zone to go through special studies through Soils and Geology's report to make sure that the building's engineered correctly. All right, folks, we're almost done. We've got through part one, which is most of this chapter. Part two now, we're just going to follow up on two things, and I'm going to just leave out the third one. Composite land suitability analysis is when you look at an area and you map out all of the different environmental factors that are there. So you're going to look at the slopes, you're going to look at soils, you're going to look at habitats, you're going to look at hazard areas. You're going to put all of those on a different layer within the same map. You're going to show all your roads, your sewer lines, your infrastructure. So on each layer, you're going to put those different features. And as you start to put those features on top of each other, you're going to start to see areas where development can occur without triggering any sort of impacts in those areas. If you have an area where there's no seismic hazards, where there's no wildlife habitat, where you don't have any soil issues, that's going to be the area where you want to focus growth, if not your most dense growth, and there. We did something similar with this, like when we did a master plan for Las Encinas Hospital, we had them go out and create a map of where the tree canopy was on the site, where the scenic vistas were, where all the archaeological features were, the historical features. And the area that was left was where we put the most density on the site. So it's a helpful tool to use when doing site planning or even when you're doing general plan analysis. So the second type after composite land suitability analysis is an environmental impact assessment. And this is what we're most familiar with in California, because we have what's called the California Environmental Quality Act, or CEQA. Nationally, it would be NEPA. And so the purpose of this process is to figure out how a project, or even a project can be a general plan or a specific plan, or how a specific construction project is going to affect the environment. And so what you have is you start off with a checklist of all the different environmental factors that you have to study. And in CEQA, it's a bunch. It goes from aesthetics, agriculture and forestry, air quality, biological resources, cultural resources, geology and soils, greenhouse gas emissions, hazards and hazardous materials, hydrology and water quality, land use planning, mineral resources, noise, population and housing, public services, recreation, transportation, traffic, and utilities and service systems. So you go through all of that, you go through that checklist, and you determine whether this project is going to have a less than significant impact, a significant impact, or less than significant with mitigation, or no impact. So you have all these different categories of impacts. And so as part of that, then you're going to have to do usually a lot of studies that go with that. If your project's not exempt in CEQA, you're probably going to do an air quality analysis. You're going to do a traffic analysis. You might do a geology and soils analysis, a biological resources analysis, depending on the type of project you're proposing. And then if your project is determined to have a significant impact on the environment, you need to disclose that to the public. So when you think environmental impact assessment, think what we do in California in terms of environmental analysis. So just as a matter of conclusion, we went over the first part of this topic, which was about how to do an environmental inventory. We talked about topography and slopes, soils, wetlands, fragmentation of habitats, watersheds, and hazards. And if I were you getting ready for a quiz or a midterm or a final, I would think it'd be very important to know what are the different government organizations, administrations, and what is the information that they provide. So who provides soils information, who provides topography and slope maps, who's providing information on habitats and the wildlife. And then the second part of this lecture, we looked at the different ways of reviewing those different environmental factors. And so we talked about land suitability analysis and looking at a composite land suitability analysis is what the textbook says. Looking at all those different layers of information and figuring out what land is most suitable for development. And then we talked about the environmental impact assessment, which in California we would call CEQA, nationally NEPA. And that checklist that you would start off with, and you'd go through whether whether your project creates these impacts, and if so, at what level. And then we completely skipped over carrying capacity, because if you really want to look at carrying capacity, you're going to hire an expert to help you with that, and they're going to take over that analysis for you.